So picture this. You've poured everything into building this amazing generative AI application. It's live, it's in production, and all your dashboards are glowing green. But something just feels off. Your users are complaining, costs are looking a little weird, and you just can't put your finger on why. Today, we're going to pull back the curtain on Gen AI observability and show you how the experts see what's really going on inside these incredibly complex systems.
You know the scene. As soon as a Gen AI app starts acting up, this is the first thing you hear. Someone sees a couple of strange outputs and immediately declares the model is bad, it's broken. But here's the secret that the pros know. That explanation, it's almost always wrong. See, large language models don't really break like a line of code. They don't just throw an error and stop. No, they drift. Their behavior shifts in these subtle ways that can have absolutely massive consequences down the line. Okay, so if the model isn't just breaking, then what in the world is really going on under the hood? Well, that's the big question we're going to tackle. Think of this as a detective story, and we're about to find the real culprit behind these mysterious failures. Let's kick things off with a scenario that, I guarantee you, keeps engineering managers up at night. It's what we call a silent failure, where everything looks perfectly fine on the surface, but your system is completely failing your users. So you push a new fine-tuned version of your model to production. You check your monitoring tools, the ones for CPU, memory, network traffic, and it's a sea of green checkmarks. Everything is healthy. But the support tickets are starting to pile up. Customers are saying the answers are weird or they're not helpful. You, my friend, are in the middle of a major production incident, and your tools are telling you everything is just peachy. This is the mystery of the silent failure.
To solve this mystery, we have to start thinking differently. We need to realize we're hunting an entirely new species of bug here, one that requires a totally new playbook compared to traditional software.
And this, right here, this is the heart of the issue. Traditional code is deterministic. You put X in, you get Y out, every single time. There's a clear, correct answer. But Gen AI models, they're probabilistic, they're creative. For any given prompt, there's no single right answer. Your old debugging tricks, they just don't apply anymore.
So, if we can't check for correctness, what do we check for? We check for this: behavioral stability. This is the new North Star. What we're asking now is, does the model still behave the way we expect it to? Is it keeping its core personality, its tone, its helpfulness day after day?
And this is the absolute key, the big mental shift you have to make. You've got to stop asking, is this answer right? And start asking, is this behavior stable? You're not a code debugger anymore. You're more like a behavior analyst for a really complex digital mind. Okay, so we know we need to monitor behavior. Awesome. But what does that actually mean? What are we looking for? Well, let's break down the 5 non-negotiable signals that every expert out there is tracking.
All right, number 1, model identity. You have to know exactly which version, which hash you're looking at. If you don't, you're flying blind. 2, token economics. Are your answers suddenly getting twice as long? That's not just a style change. That's a direct hit to your wallet. 3, confidence. We're looking at things like log probs and entropy here, which is just a fancy way of asking, how sure is the model about the words it's picking? A sudden drop in confidence is a huge red flag. 4, output shape. This is your canary in the coal mine. Tiny shifts in length or structure often show up right before a huge behavioral break. And finally, number 5, safety and refusals. If your model starts refusing to answer simple, safe questions, that's a problem. If it stops refusing to answer dangerous ones, that's an even bigger problem.
So we have the theory, we have the signals, now let's get our hands dirty and see how this all comes together in the real world. We're going to use these signals to crack the case on a real example of model drift. Okay, let's go back to our crime scene, that production incident. A new fine-tuned model was deployed. Infrastructure looks great, but the users are unhappy. Now the data from our 5 key signals is about to tell us exactly what went wrong. And there it is, the smoking gun. The average number of output tokens shot up from 180 to 310. Suddenly, the model got super chatty. At the exact same time, the refusal rate more than tripled. And that hallucination score? It started to creep from low to medium. The model's entire personality had changed right under our noses.
And here is the real kicker. That little change in wordiness had a massive business impact, a 41% increase in operating costs, a 41% jump. And all of this happened with zero infrastructure errors, zero traditional alerts. This system was just silently bleeding money because its behavior had changed. And hey, while we're talking about hallucinations, you don't need some perfect truth detector. The real key is to track the trend of these related signals. Is the model getting wordy but also less confident? Is it making stuff up that doesn't match the context you gave it, especially in a RAG system? Are you seeing it contradict itself more often? Tracking the trend of these things is how you catch problems before they become a full-blown crisis.
So let's bring this all home. To really monitor a modern AI system, you need two totally different but equally critical types of observability. You're really asking two very different questions. The first question is the one we've been asking for decades. Is the system fast and alive? Are the servers on? Is the network okay? Is latency low? This is classic infrastructure observability. It's absolutely crucial, but as we've seen, for GenAI, it's dangerously incomplete. It only tells you if the lights are on in the building. The new essential question we have to ask now is this. Is the model still who we think it is? Is it still acting like that helpful, cost-effective, and safe model we spent so much time testing and decided to ship? And that is model observability. It's the missing piece of the whole puzzle. It doesn't just tell you if the lights are on, it tells you if the pilot is actually flying the plane in the right direction. Because without it, the cost of not knowing is huge. Your costs just silently creep up. User trust, which is so incredibly hard to build, just slowly evaporates with every weird answer. Failures seem totally random, impossible to pin down. And eventually, your AI just becomes unusable, not because it's down, but because you just can't trust it anymore. So, the final thought I want to leave you with is this. Your AI is online. Your dashboards are green, your servers are humming away, but you have to ask yourself, is it still the model you thought you deployed? Is it still the one you trust with your customers and your budget?